As you see in the previous lesson video, to connect the timber or wood to other structure, we need to be notch or bevel or curve. And how to determine the safe vertical reactions with the N notch. You see in this equation here that RV, safe vertical end reactions, and FV stand for allowable shear stress, which depends on the wood, the type of wood that we are working on, and B, the width of the beam, D, the depth of the beam, and D sub E, the depth of the beam above the notch as defined in that figure. And you also see that in the previous lesson video. When the notch is curved or beveled over a distance greater than DE, so what does that mean? The distance here is greater than DE, which is the depth of the beam above the notch, and here curve greater than DE, and DE defined by definition that is the depth of the beam above the notch. So if whether that beam is curved or bevel with the distance as I showed greater than DE, then we can apply the safe vertical reaction by RV equal to 2 FV BDE over 3. And all the parameters are the same as the previous equation. And now let's apply that in problem 2. A 2 by 10-inch floor joist has the end notch on the bottom to the depth of 3 inches. The notch is beveled over a distance of 7 inches. If the allowable shear stress is 185 psi, what is the maximum safe vertical reactions at the end of the joist? So let's draw the joist, and we have 2 by 10 inches, and that is a nominal cross section, and then it will be bevel over a distance 7 inches. So you have that bevel 7 inches, and then it becomes to the normal, and that's what you have for section of that beam. Continue, and for this one they give us, you see the bottom, from the bottom to the depth 3 inches, so at that is 3 inches as you can see there, and bevel over a distance 7 inches, so that one here is 7 inches. And the question becomes is what is DE, and this is the DE we want to find out. What is DE first? That is DE. And the cross section of this beam, as you can see, is 2 by 10. So let me draw the cross section of that cross section. So 2 by 10 is the nominal reaction, not the actual reaction. So with that, if you have 2 by 10 inch, then what should be the actual dimension? With that, you go to the final exam reference for this class and go to page number 7. Go to page number 7. We have the standard lumber and timber section properties, and as you can see there, nominal size that I just tell for this joist is 2 by 10. So if you see that it's 2 by 10 here, then the actual size, as you can see there, is 1.5 cross or time 9.25 inches. So that what is the 2 by 10 in nominal dimension. The actual is 1.5 times 9.25. So keep that in mind when you find out the actual dimension, and that is suppose we need to find out, and that go to the reference. So here you have that it will be 9.25 inches, and believe it or not, this is 1.5 inches. Even the nominal is 2 by 10. So where that come from? Go to the this one. You go to the reference. Okay, page number 7. Page 7. That you can see there. And that is the cross section of cross. So from that here, we know B is 1.5, and the depth, the actual depth of that one is D, and that is 9.25 inches. So from that we can find out the E, and you can see equal to 9.5 minus 3, so it will be 6.25 inches, and you can see that. So with that we can be able to, and that one is B 1.5 inches, so we can apply the equation previously. Here RV equal to 2 FV B dE over 3, then we can have the shape reaction, vertical reaction, equal to 2 FV B dE over 3, and we plug in 2 FV in PSI, so you have 1.185 PSI. B, the depth, the width of the beam, with the nominal size 2, so 1.5, as I show you, so it will be 1.5 inches, time the DE is 6.25 inches, and then divide by 3. And from that we will get 1,542 pounds. 1,542 pounds. And that is the shape reaction at the end of this notch. And that problem 2. So again, to use this, we need to go to the reference to find out what is the actual size of the nominal size of the choice. That's something you go to Lowe's or Home Depot to get. They say the cross section is 2 by 10, the actual size. When you determine the reaction, something for engineering, we need to go to the actual size, and that go to the reference.